Good morning, students. Today we are going to continue with exercise 10.5. In the previous classes we have discussed about the order and degree of the differential equation. Again we studied to form the differential equation for the given linear equations, right? Today we are going to solve the differential equation. In solving of differential equation, we are going to study some different methods. The first method is called variable separable method. Then the second method is called homogeneous. Then the third one is called linear differential equation in first order. Then we have second order differential equation also. Right now in 10.5 we will discuss only about the variable separable method. See the first question from this exercise. See the first question. If F is the constant force generated by the motor of an automobile of mass m, its velocity v is given by the relation m into dv by dt is equal to f minus kv, where k is a constant. Express v in terms of t, given that v is equal to 0 and t is equal to 0. See, given that m into dv by dt is equal to f minus kv, here the variables are v and t. We are going to study about the term variable separable method, right? So variable separable means we have to separate the variables. Here the variables are v and t. Now we are going to separate the variables v and t. We are going to keep one variable v in one side, the other variable t in the other side. So what we can do is, we can bring this the whole term, v term, into the denominator. See, dv by f minus kv, which is equal to dt. Here we have m. So m into dv by f minus kv is equal to dt. Just we have brought this term to the denominator. Okay. So now look at the terms now. This side v term, okay, v term, here dt. Here this m, f and k are all constants. Okay. Now after separating the variables, then we have to integrate. When we are integrating, we will get integral of m into dv by f minus kv is equal to integral of dt. Here just we applied one integration symbol on both sides. Here m is the constant term, so bring it outside. M into integral of dv by f minus kv is equal to integral of dt. It is in the form integral of dx by x. Integral of dx by x is equal to log x. That means the differentiation of denominator is there in, see, the differentiation of denominator is there in numerator. The answer is what? Log of denominator. See, the differentiation of x is 1 into dx. Differentiation of denominator is there in numerator. The answer is what? Log of denominator, log of x. Differentiation of x is 1 into dx. That is why we are writing log x. The similar way, here the differentiation of f is a constant, so 0. Then minus k is also a constant. Differentiation of v is 1 into v, right? 1 into dv. But this k into 1 into dv. We need this term in the numerator. But it is not there. So what we can do is, we can multiply 1 minus k on both sides. Why we are going to multiply? In order to get the differential format. See, m into integral of minus k into dv by f minus kv is equal to minus k into integral of dt. So here we have multiplied 1 minus k on both sides. Now let's check the terms. Denominator is the differentiation of f is 0, okay, minus k into differentiation of v is 1 into dv. Is there, right? See, minus symbol is there. Differentiation of k into v is k into 1 into dv. So here we have the differentiation of denominator is there in the numerator. So what can we apply? Log of denominator. That is m into, instead of writing this, we can write log of denominator, that is f minus kv. That side, minus k into integral of dt. Integral of dx is x. Integral of dy is y. So integral of dt is t. Then after integrating, we have to apply one constant. Reason is, integral of x raised to n dx is x raised to n plus 1 by n plus 1 plus c. Integral of cos x is sin x plus c. Integral of e power ax is e power ax by a plus c. So after integrating, we have to apply the constant term, one constant term. Okay? Now we are going to apply the given condition. What is the given condition? It is given that t is equal to 0, v is equal to 0. See, in the question, the last line it is given. Our aim is to express v in terms of t, given that v is equal to 0 when t is equal to 0. Apply the condition in the equation. We will get m into log of f minus k into 0, which is equal to t0, 0 plus c. That means m into log f, k into 0 is 0. So we can leave the term, right? Which is equal to c. If we apply this term in this equation 1, we will get equation 1 implies m into log of f minus kv is equal to minus kt plus c. The constant c is equal to m into log f. This m into log f. See, here one log term, here also one log term. So we can keep the log terms together. For that, we are bringing this term into the left hand side. So we will get m into log of f minus kv minus m into log f, which is equal to minus kt. Here one m common. If you are taking m outside, or we can do one thing, divide by m. When we are dividing by m, here we will get log of f minus kv minus log f, which is equal to minus kt by m. See, when we are dividing by m, here this m will go, here also it will go, but here kt by m we will get. Now, we know very well log a minus log b. log A minus log B is log of A by B. Log A minus log B is equal to log of A by B. So we can express these terms. See, log of this is our A, this one is our B. So log A minus log B. Log A minus log B is log of A by B. That is F minus KB by F, which is equal to minus KT by M. Now we are going to remove the logarithm. For removing logarithm, we need to take exponentiation on both sides. When we apply exponentiation on both sides, we will get e power log of f minus kb by f is equal to e power minus kt by m. E and log, see, e power log, which is equal to 1, or log e and e power log getting cancelled. So it will become 1. So it will become 1. So what is the remaining term? F minus kb by f is equal to e power minus kt by m. But here our aim is to find the value of v. We have to express v in terms of t. So our aim is to find this v. For finding this v, what can we do? We can cross multiply this f to the right hand side now. When we are cross multiplying f minus kb is equal to f into e power minus kt by m. Now bring this f into the right hand side. So we will get minus kb is equal to f into e power minus kt by m minus f. Now we need only v. So v is equal to divide each term by minus k. So f into e power minus kt by m. Kt by m. This k is coming down. Or we can do one thing. See, one f is common, right? Take the common term f outside. When we are taking f outside, e power minus kt by m minus 1. Now bring down this minus k. So v is equal to f by minus k. F by minus k into e power minus kt by m minus 1. If we take this minus 1 into inside the bracket, it will become f by k. F by k into, when we multiply minus k inside, it will become minus, this one, minus 1 becomes plus 1. So 1 minus e power minus kt by m. So we have expressed v in terms of t. Okay? Now see the second question. The velocity v of a parachute falling vertically, it satisfies the equation v into dv by dx equal to g into 1 minus v square by k square, where g and k are constants. If v and x are both initially 0, then find v in terms of x. So it is given one differential equation, that is v into dv by dx equal to g into 1 minus v square by k square. Now we are going to consider this equation. First we are going to separate the variables v and x. Here the variables are v and x. Before separating the variables, here we want to take the LCM. So v into dv by dx is equal to g into, when we are taking LCM, k square is the LCM, cross multiply. So k square minus b square. Now we are going to separate the variables. This is a single term. Bring it down. So here we have v and dv by k square minus b square, which is equal to, here the leftover things, g and k square. Now cross multiply this dx into the right hand side. Now check the terms. All the terms. See here in one side, the left side, v terms are there. In the right side, only the x terms. This v is taken, brought into the left hand side, right? G, k square, this dx. Okay. So after separating the variables, we have to apply integration. When we are integrating, integral of v into dv by k square minus b square is equal to integral of g by k square into dx. See, in the first term, already in the previous question I said the differentiation of denominator is there in numerator. We can apply logarithm of denominator. See, k is a constant. So differentiation of any constant is 0. Okay, then this minus differentiation of v square is 2v into dv. But in the numerator we have only v and dv. There is no minus 2v. So what we are going to do is, we can multiply one minus 2 on both sides. When we are multiplying minus 2 on both sides, we will get minus integral of minus 2v dv by k square minus b square, which is equal to minus 2 into integral of g by k square into dx. See, here just we multiplied one minus 2 on both sides. When we are multiplying the same constant on both sides, there won't be any change in the equation. Okay. Now once again check the terms. Differentiation of denominator. The differentiation of k square is 0. Then minus. Differentiation of b square is minus 2v dv. So the differentiation of denominator is there in numerator. So we can apply log of the denominator, that is k square minus b square. In the right hand side, minus 2 g and k square. These are all constant. So what is the leftover term? Integral of dx. What is integral of dx? Integral of dx is x. So after integration, we have to apply one constant. Okay. Now, apply the given conditions. What is the given condition? It is given that v and x are both initially 0. See the question, the last line. If v and x are both initially 0, then find v in terms of x. So that means when v is equal to 0, x is equal to 0. Apply the condition in the equation. When we apply v is equal to 0 and x is equal to 0, it will become log of k square minus 0, which is equal to x 0 means 0 in number 0. It will become 0, 0 plus c. Therefore, c is equal to log of k square. Apply the constant term c in this equation 1. It will become log of k square minus b square is equal to minus 2g by k square into x plus c. C means log of k square. See, in left hand side one log term, in right hand side also one log term. So we can keep the log terms together. when we are bringing this log term into the left hand side, it will become log of k square minus b square minus log k square, which is equal to minus 2g by k square into x. Now, log a minus log b. Log a minus log b is log of a by b. So, log of k square minus b square by k square, which is equal to minus 2gx by k square. Now, we are going to eliminate this logarithm. How can we eliminate logarithm? By applying exponentiation on both sides. When we apply exponentiation on both sides, it will become e power log of k square minus b square by k square, which is equal to e power minus 2gx by k square. E log getting cancelled. So, what is remaining? K square minus b square by k square is equal to e power minus 2gx by k square. But our aim is to find the unknown b square. So, these two k square we have to remove now. Remove from the left hand side. So, just cross multiply this k square into the right hand side. So, it will become k square minus b square is equal to k square into e power minus 2gx by k square. Again, we have to bring this k square into that side. So, minus b square is equal to k square into e power minus 2gx by k square. Then this k is moving into the right hand side, it will become minus k square. Here one k square constant, k square is common. Take the common term outside. When we are taking the common term, k square into e power minus 2gx by k square minus 1. This is minus b square. So, what is b square then? Take this minus into the right hand side or just multiply 1 minus 1. So, it will become b square. Here, when we multiply minus 1, it will become minus, this term will become positive. So, k square into 1 minus e power minus 2gx by k square. So, this is the required result. Our aim is to represent v in terms of x. Now see the third question. Find the equation of the curve whose slope is y minus 1 by x square plus x and which passes through the point 1, 0. We know very well slope. Slope means dy by dx at one point. Here the point is given 1, 0. So instead of slope, we can write dy by dx. Reason is slope means dy by dx at the point x1, y1. So we can take slope dy by dx is equal to y minus 1 by x square plus x. Now we are going to separate the variables. See, y term, so we can bring it down. This x term, we can take it into the numerator. So we will get dy by y minus 1 is equal to dx by x square plus x. That is dy by y minus 1 is equal to dx by, here one x is common. If you are taking x outside, it will become x plus 1. Now apply integration on both sides. If we apply integral symbol on both sides, integral of dy by y minus 1 is equal to integral of dx by x into x minus 1. See the left hand side. Differentiation of denominator. See, differentiation of denominator is differentiation of y is 1 into dy minus differentiation of the constant 1 is 0. So, we have the differentiation of denominator in the numerator, but in the right hand side it is different. So, first we are going to consider this term 1 by x into x plus 1. We are going to split this term 1 by x into x plus 1 as sum of two terms with the help of partial fraction. So consider the term 1 by x into x plus 1. See, for this we can apply the formula, integration formula. Here there is no such formula. That is why we are going to split this term 1 by x into x plus 1 into the sum of two terms, okay, with the help of partial fraction. We know partial fraction very well. So 1 by x into x plus 1 can be written as a by x plus b by x plus 1. Now take the LCM of the right hand side. See this side. If you are taking the LCM, what will get? X into x plus 1. So cross multiply a into x plus 1 plus b into x. The left hand side we have 1 by x into x plus 1. Cancel the common terms. So we are having now 1 is equal to a into x plus 1 plus b into x. So from this relation we have to find out the terms a and b by applying different values for x. When we apply x is equal to minus 1, when we apply x is equal to minus 1, minus 1 plus 1, 0. So this term will vanish. The same time we can get the answer of b. Similarly, when we apply x is equal to 0, this b term will vanish. We will get the value of a. Now apply x is equal to minus 1. So 1 is equal to a into minus 1 plus 1 plus b into minus 1. Minus 1 plus 1 is 0. 0 into a is 0. So 1 is equal to 0 minus b. So minus b is equal to 1. Therefore b is equal to minus 1. Similarly, we can apply x is equal to 0. When we apply x is equal to 0 in this relation, it will become 1 is equal to a into 0 plus 1 plus b into 0. b into 0 is 0. So we can leave this term. 1 into a is a. So a is equal to 1. Therefore, this expression, see, 1 by x into x minus 1 is equal to a. The value of a is 1. The value of b is minus 1. So, apply this value here, a and b. Therefore, 1 by x into x plus 1 can be written as 1 by x plus b value is minus 1. So, minus 1 by x plus 1. Now, we can apply this value in the original equation, integration, this equation. So, instead of 1 by x into x plus 1, we can write 1 by x minus 1 by x plus 1. Okay? So, equation 1 becomes integral of dy by y minus 1 is equal to integral of 1 by x plus into minus minus 1 by x plus 1 into dx. See, differentiation of denominator is there in numerator, right? The differentiation of y is 1 into dy. Differentiation of minus 1 is 0. So we can apply the formula log of denominator. Similarly, when we multiply dx inside, so dx by x, integral of dx by x. So differentiation of denominator is there in the numerator. So we can apply log of the denominator minus, here also same. Differentiation of x is 1 into dx, constant is 0. So log of denominator. So after integration, we have to apply one constant c, right? But the terms are coming logarithm, means we can write the constant term in terms of log. So that is log c. Is it clear? Okay. Now, log of y minus 1. In logarithm, addition means, see, log of a plus log of b, log of ab. So addition means multiplication. There is subtraction coming, means, see, log of a minus log of b is log of a by b, right? So we can simplify this term, see, log of x by x plus 1. Subtraction means division, here multiplication, so into c. When we apply exponentiation on both sides, see, our aim is to remove this logarithm on both sides. So we can apply exponentiation on both sides. E power log of y minus 1 is equal to e power log of xc by x plus 1. So e log getting cancelled, e log getting cancelled. So what is remaining? Y minus 1 is equal to xc by x plus 1. Now, finding this constant c, we can apply the point. It is given that the curve passes through the point 1, 0. This curve passes through 1, 0. That means x value is 1, y value is 0. So it will become 0 minus 1 is equal to, x is 1, right? So 1 into c by 1 plus 1. 1 plus 1 is 2. When we cross multiply, it will become minus 2. Reason is already there we have one minus. So minus 2 is equal to c. Now we are going to apply the c value in this equation. When we apply c value in this equation, it will become y minus 1 is equal to x into minus 2 by x plus 1. Bring this 1 into the right hand side. So y is equal to minus 2x by x plus 1 plus 1. If you are taking the LCM, x plus 1, cross multiply, so minus 2x plus 1 into x plus 1 is x plus 1. So 1x minus 2x is minus x by x plus 1. This is the required curve. Now come to the next question. Question number 4. Solve the differential equation dy by dx equal to square root of 1 minus y square by 1 minus x square. That is, dy by dx is equal to, we can split the square root into 2, that is root of 1 minus y square by root of 1 minus x square. The reason is root of a by b can be written as root a by root b. Similarly, root of ab means root a into root b. So we can split this single term into two, right? Our main aim is to separate the variables. In this equation, we can easily separate the variables. Just interchange the two terms. When we are bringing this term here, this dx will move to the numerator. See, dx by square root of 1 minus y square is equal to dx by square root of 1 minus x square. Now see, we have separated the variables y and x. Left side all y terms, right side all are in x. So after separating the variables, we can integrate, right? So integrating on both sides. When we are integrating, we will get dy by square root of 1 minus y square is equal to integral of dx by root of 1 minus x square. Both sides just we applied one integration. We have studied integral of dx by root of 1 minus x square. Integral of root of 1 minus dx by root of 1 minus x square is sine inverse of x. So, this term integral of dy by root of 1 minus y square can be simplified as sine inverse of y. Sine inverse of y is equal to here the same format only. So, we can write sine inverse of x. So, after integration, we have to put one constant, integrating constant c. So, that's all. Now, we can move on to the second subdivision. The second subdivision says, solve the equation y into dx plus 1 plus x square into tan inverse of x into dy is equal to 0. In this part, we are focusing the separating the variables, right? So, the separation of variables means we have to separate x in or x terms in one side, y terms in the other side. So, what we can do is we can bring this term dx terms to the right hand side. So, it will become 1 plus x square into tan inverse of x into dy is equal to minus y dx. Our main target is to separate the variables. These are all x terms. So, bring this term into the right hand side. This y term we don't want here. So, bring it in the left hand side. So, dy by y is equal to minus dx by 1 plus x square into tan inverse x. So, here we have separated the variables x and y. One side full of y, another side full of x. So, after separating the variables, we need to apply integration. When we are integrating, what will get? Integral of dy by y is equal to minus integral of dx by 1 plus x square into tan inverse of x. See the left hand side, it is in the standard form. Integral of dy by y, integral of dx by x is log x. So, integral of dy by y is log y. So, we can apply the formula. But in the right hand side, it is very difficult. There are two functions. So, we can take this tan inverse as another variable. Let us take u is equal to tan inverse x. Then what about du? Du is equal to differentiation of u is tan u. Sorry, du. Differentiation of tan inverse x is 1 by 1 plus x square into dx. So, this equation, this terms minus integral of dx. See, dx by 1 plus x square, dx by 1 plus x square, dx by 1 plus s square. So, both are the same, right? So, dx by 1 plus s square is nothing but du. So, we can replace these two terms as du. Reason is dx by 1 plus x square, dx by 1 plus s square is equal to du by this tan u. Tan u already taken as 1u. Is it clear? Okay. So here we have integral of dy by y. Now apply the integration formula. Integral of dy by y is log y. Reason is differentiation of denominator is there in the numerator. The answer is log of denominator. So log of y minus here log of u. So the integration terms are coming in logarithm, means the constant, the integrating constant is also log. So we can write the represent the constant in logarithm, that is log c. So log y is equal to, see here, log a minus log b. Log a minus log b is log of a by b. So log of c by u. Now we are going to eliminate this logarithm. How can we eliminate? By taking exponentiation on both sides. When we are applying exponentiation on both sides, e power log of y is equal to e power log of c by u. Then after eliminating logarithm, we can apply the term u. Reason is we only consider u as tan inverse x. So we have to replace the unknown u. Okay? Therefore, we are going to apply exponentiation e power log y is equal to e power log of c by u. This e and logarithm getting cancelled, so y. Here also e and logarithm getting cancelled, so you get u c by u. But what is our u? U is tan inverse x. Therefore, y is equal to c by tan inverse x. Y is equal to c by tan inverse x. Cross multiply this tan inverse. So y into tan inverse x is equal to c. This is the required solution. Okay, students. Now let's move on to the next question. The third subdivision. Solve sin of dy by dx equal to a, where y of 0 which is equal to 1. This means when x is equal to 0, y is equal to 1. That is y of 0 means we have to apply when x is equal to 0, we will get y is x equal to 0 means y is equal to 1. That's the meaning. Okay, anyhow, first we are going to solve the equation, that is sin of dy by dx is equal to a. Now we are going to take this sine function into the right hand side, or just multiplying one sine inverse on both sides. When we are multiplying sine inverse on both sides, sine inverse or sine, that is getting cancelled. So we will get dy by dx. That side we will get sine inverse of a. Our main target is to separate the variables. When we are separating the variables, dx will move to the next side, that is dy is equal to sine inverse of a into dx. See, one side full of y term, another side full of x term. So, after separating the variables, we have to apply integration. When we are applying integration or integrating, we will get integral of dy is equal to sine inverse of a into integral of dx. Sine inverse a is one constant. Now, what is integral of dx? Integral of dx is x. Integral of dy is y. So, this term will become y into sine inverse of a. Sine integral of dx is x. After integrating, we have to apply the integrating constant, that is c. Now, for finding the unknown c, it is given that x is equal to 0, y is equal to 1. When x is equal to 0 and y is equal to 1, it will become 1 is equal to x 0, 0 number 0, so 0 plus c. That means c is equal to 1. Apply the value c here. Therefore, the required solution is y is equal to sine inverse of a into x plus 1. Okay. Now, let's move on to the next question. The next question is subdivision 4. Subdivision 4, dy by dx is equal to e power x plus y plus x cube into e power y. Solve the differential equation dy by dx equal to e power x plus y plus x cube into e power y. dy by dx is equal to, this e power x plus y can be split into two, that is e power x, e power y. We know very well a power m into a power n is a power m plus n. So, e power x into e power y is e power x plus y plus x cube into e power y. Here e power y common. So, if you take e power y outside, what is remaining? E power x plus x cube. Here we have dy by dx. Now, we are separating the variables. Bring this y term into the left hand side, this dx into the right hand side. So, dy by e power y is equal to e power x plus x cube into dx. So, after separating the variables, we have to apply integration. When we are integrating on both sides, we will get integral of this e power y. We have to bring this e power y into the numerator. So, it will become e power minus y. 1 by a power m is equal to a power minus m. Similarly, 1 by e power y becomes e power minus y into dy, which is equal to integral of e power x plus x cube into dx. Integral of e power minus y. Integral of e power x into dx is equal to e power x. But integral of e power ax into dx is e power ax by a. So, here in place of a, we have minus 1. So, e power minus y by minus 1. Integral of e power ax into dx is e power ax by a. So, here in place of a, we have minus 1. So, integral of e power minus y into dy is e power minus y by minus 1, which is equal to integral of e power x, that is e power x. Integral of x cube, it is in the form x raised to n Integral of x raised to n. Integral of x raised to n is x raised to n plus 1 by n plus 1. So, x raised to 3 plus 1 by 3 plus 1 plus 1c. Now take this minus 1 into numerator. So minus e power minus y is equal to e power x plus x raised to 4 by 4 plus c. That is e power x. If you are taking this negative term into the right hand, it will become positive. So e power minus y plus x raised to 4 by 4 plus c, which is equal to 0. So this is the required solution. Is it clear? Okay. Now move on to the next subdivision. Subdivision 5. See the question. Solve e power y plus 1 into cos x into dx plus e power y into sin x into dy is equal to 0. The first step, we can take this term into the right hand side. So we will get e power y sin x into dy is equal to minus e power y plus 1 into cos x into dx. Now we can easily separate the variables. See, e power y dy. This sin x, we don't want this side. So bring it that side. Here we have cos x into dx. This y term, we can bring it into the left hand side. So e power y into dy by e power y plus 1, which is equal to, there we have minus cos x into dx. The sin x is moving this side, sin x. So after separating the variables, we can apply integration. When we are integrating, what will get? Integral of e power y into dy by e power y plus 1 equal to minus integral of cos x by sin x into dx. Is minus, you can bring it into outside of the integral. Okay. Reason is inside, the negative sign no need. See, differentiation of denominator, e power y differentiation is e power y. Constant differentiation is 0. So we have the differentiation of denominator in the numerator. So what can we apply? Log of the denominator. So log of e power y plus 1, which is equal to minus sin x differentiation is cos x. So the differentiation of denominator is there in the numerator. So we can apply log of the denominator plus c, logarithm, logarithm. So the constant is also in log. So log c. The integrating constant is log c. Now we can simplify the terms. Log of e power y plus 1 equal to log a minus log b. Log a minus log b. Log a minus log b is log of a by b. Now apply exponentiation on both sides. When we are applying exponentiation, e power log of e power y plus 1, which is equal to e power log of c by sin x. So e and log getting cancelled. So we'll get e power y plus 1. That side e log getting cancelled. C by sin x. When we cross multiply the sin x this side, we will get sin x into e power y plus 1, which is equal to c. This is the required equation, required solution. Now we can move on to the next subdivision, that is subdivision 6. The question is, solve y dx minus x dy into cot of x by y, which is equal to n into y square into dx. So we can separate the variables now. When we are bringing this y square into the left hand side, we will get y dx minus x dy by y square into cot of x by y, which is equal to n into dx. We know very well differentiation of x by y, it is in u by v form. U by v. U by v differentiation is u into v dash minus v into u dash minus u into v dash by v square. The same term we have here, right? So instead of writing these terms, we can write the simple term d of x by y. Again we have one more term, that is cot of x by y, which is equal to n into dx. Now apply integration. When we are applying integration on both sides, integral of cot of x by y into d of x by y. Integral of cot x into dx. Integral of cot x into dx is log sin x. So here the variable x, here also dx. Suppose if we have y, cot y dy, then what is the answer? Log of sin y. Similarly, x means x, y. Suppose if you have t, cot t into dt means log of sin t. Similar way, here cot of x by y into d of x by y. In place of x, here x by y. So x by y, x by y. So it is same like cot x dx. It is same like cot x into dx. Cot x into dx is log of sin x. So cot of x by y into d of x by y is log of sin of x by y, which is equal to n into integral of dx is x plus 1c. Is it clear? Okay. Now we are going to remove this logarithm. How can you remove logarithm? By taking exponentiation on both sides. So e power log of sin of x by y is equal to e power nx plus c. E log getting cancelled. So sin of x by y is equal to e power nx into e power c. E power or a power m plus n. A power m plus n can be written as a power m into a power n. So e power nx plus c can be written as e power nx into e power c. C is one constant. So e power c is also a constant. So instead of e power c, we can write another c, another one constant. For example, e power 6. E power 6 is a constant. So the same way, we can rewrite this e power c as another constant c. So it will become sin of x by y is equal to c into e power nx. This is the required solution. Now we can move on to the next subdivision, that is subdivision 8. Subdivision 7 and 10 are not there in our syllabus now. That is the reduced syllabus. We have question number 5, 6, 8 and 9. Okay. Now we can move on to the next question, question number 8. Question number 8 is solve the differential equation x into cos y into dy is equal to e power x into x log x plus 1 into dx. X into cos y into dy is equal to e power x into x log x plus 1 into dx. See, right hand side full of x, but left hand side we have x and y term. So we can bring this x to the denominator. So cos y into dy is equal to e power x into x log x plus 1 into dx divided by x. When we are dividing each term by x, we will get e power x, x log x by x plus e power x into 1 is e power x into dx by x. X getting cancelled. So, cos y into dy is equal to e power x into log x plus e power x into dx by x. Now apply integration. When we are integrating, what will get? Integrating integral of cos y into dy is equal to integral of e power x into log x. See here, this dx and e power x is common for these two terms, right? When we are multiplying e power x and dx, here on dx will come. So dx plus, okay, so log x into dx plus integral of e power x dx by x. This dx is common for both the terms. So e power x, x log x dx. Similarly, e power x into 1 into dx. Okay. Now consider this expression, that is integral of e power x by log x into dx. First we are going to find out the integration of this term. Okay. See, consider the term integral of e power x into log x into dx. How can we integrate? By integration by parts. There is one method, integration by parts. This type already we have studied in class 11. That is integral of u dv form. Integral of u dv, that is uv minus integral of v du. For choosing the function u, we are using the rule Eilert. The first preference is for inverse trigonometry function. Then the second preference is for logarithmic function. If there is no inverse trigonometric, there is no logarithm, then only the third preference is for arithmetic function, then trigonometry function, the last only the exponential function. In our question we have exponential function and logarithmic function. So the first preference is for log. So let u is equal to log x. After taking the u function, the remaining full is dv. So dv is equal to e power x into dx. See, u and dv, only two function. This is our u, the remaining all are dv. Now, our aim is to get u and v. So u is there, then we are need of v. From this dv, we can get v by integrating. So just apply integration on both sides. Integral of dv is equal to integral of e power x dx. So v is equal to e power x. Integral of dv is v. Integral of e power x dx is e power x. then we need du. So this function we have to differentiate. So du is equal to differentiation of u is du, differentiation of log x is 1 by x dx. Or simply we can do the first function differentiate, the second one we have to integrate. Okay, so now we got the required terms u, v and du. Now apply the formula here. Integral of e power x into log x into dx. This is in udv form, right? This is our u, the remaining all are dv. So udv form. udv form integration is what? uv. See, uv. u is log x, then v is e power x minus integral of v means e power x into du. du is 1 by x into dx. Apply this value in our question. See, we have integral of cos y dy. Therefore, apply this value here in equation 1. So, equation 1 implies integral of cos y into dy is equal to integral of e power x log x dx. e power x log x dx is log x into e power x minus integral of e power x dx by x. Then plus, here we have integral of e power x dx by x. See, plus and minus term. When we cancel these two terms, we have only two terms. Integral of cos y dy. What is integral of cos y dy? That is sin y, which is equal. Here there is no integration. So we have e power x into log x. Then after integrating, we have to put one integrating constant c. So sin y is equal to e power x into log x plus c. This is the required solution. Okay. Now we can move on to the last question from this exercise. That is question number 9. Question number 9 says tan y into dy by dx is equal to cos of x plus y plus cos of x minus y. Now we are going to solve this linear differential equation. So tan y into dy by dx is equal to cos of x plus y plus cos of x minus y. In 11th standard, we have studied cos of a plus b, cos of a minus b, right? Cos of a plus b. What is cos of a plus b? Cos a cos b minus sin a sin b. Similarly, cos of a minus b. Cos of a minus b is cos a cos b plus sin a sin b. When we are adding the two terms, we will get cos of a plus b plus cos of a minus b, which is equal to cos a cos a cos b cos b. So 2 times cos a cos b, 2 times cos a cos b. So we can simplify this term cos of x plus y plus cos of x minus y. Therefore, cos of x plus y plus cos of x minus y can be written as 2 times cos x cos y. Therefore, the question becomes, our question, what's the question? Tan y into dy by dx equal to cos of x plus y plus cos of x minus y. So instead of writing these two terms, we can write 2 times cos x into cos y. The left hand side we have tan y into dy by dx. So, here we have one y term, here also one y term, bring this y term down. So, tan y into dy is equal to 2 cos x into dx. After separating the variables, we have to do the integration. When we are integrating, integral of tan y into dy is equal to 2 into integral of cos x into dx. What is integral of tan y? Integral of tan y formula is log secant y. Integral of tan x into dx is log secant x. So, integral of tan y into dy is log secant y, which is equal to 2 into integral of cos x, that is sin x, then plus 1 integrating constant c. So, this is the required solution. Hence, we have finished exercise 10.5 now. Okay, so with this we are completing 10.5, that is the variable separable method. Okay, in the next session we will discuss about homogeneous differential equation and linear differential equation. Okay, thank you.